Okay, we're going to talk about what we have in front of you, which is the definition of the derivative. Rather than actually doing all of this math, all you really need to do from here on out is recognize what the original function is. Well, if you look at this, both this and this make it look like your original function, f of x, is actually 2x cubed. And guess what? It really is. Your original function is 2x cubed. And what we have in front of us is the definition of the derivative. That right there is the definition of the derivative. What are we taking the derivative of? We're taking the derivative of 2x cubed. So what would the derivative be? The derivative would simply be 6x squared. So instead of doing all of those algebraic manipulations, you can simply write down what the derivative is from now until the end of time. Here on B, we're looking at an original function of cosine of 5x. We're trying to take the derivative of the cosine of 5x. Well, the cosine of 5x is the negative sine of 5x, all times 5, because we got to take the derivative of the inner function, which is actually simply negative 5 sine of 5x. And that is all you're ever going to need to do again. Whenever you are looking for the derivative, and almost invariably on the AP exam, when they ask you for a limit, they're actually asking you for the derivative. You just need to spot the original function. Okay, next one. What's your original function here? Well, the only thing that kind of clues me in is maybe the sine. We might be looking at I'm sorry, I hate it when teachers do that. F of pi over 6. We might be looking at sine of pi over 6, right? Because the sine of pi over 6 is actually just 1/2. So we're looking at the derivative of sine at pi over 6. So if f of x is sine of x, then f prime of x is the cosine of x, and f prime of pi over 6 is simply the cosine of pi over 6, which is the square root of 3 over 2. Okay, onwards and upwards to inverses. A function g is the inverse of a function f if and only if f of g of x equals x for each x in the domain of g, and g of f of x equals x for each x in the domain of f. We simply call the inverse of f or we write it f to the negative 1. Over here on the graph, I have actually graphed f of x equal to e to the x, and I have reflected that. Oh, goodness gracious. I wasn't having any trouble with my pen until I needed to work quickly. And when you reflect that over the line y equals x, you in fact get f inverse of x, which is the natural log of x. Okay. Properties of inverses include that if g is the inverse of f, then f is the inverse of g. The domain of the inverse is equal to the range of f, and the range of the inverse is equal to the domain of f. Not every function has an inverse, but if a function does have an inverse, the inverse is unique. We're going to look first at f of x equals the square root of x minus 1, and we are going to find its inverse. So to get an idea of what's going on, we start with our function f of x equal to the square root of x minus 1, and we need to reflect it over the line y equals x. And we get a graph that looks something like this, and it's half of a parabola. It is not an entire parabola. It is important to notice that. We are going to use what we learned in Algebra 2, I hope. If not, you learned it in pre-cal. And we start with y equals the square root of x minus 1. And some teachers flip-flop the x and the y right away, and some people wait until the end. I'm going to do it right away, otherwise I forget. X equals the square root of y minus 1, and I'm going to solve for that y. We get x squared equals y minus 1, or y equals x squared plus 1. Now, I want you to notice that it's not the entire parabola. I already pointed that out before, but I want to make that super clear. We have a special domain here where x has to be greater than or equal to 0. So very specific restrictions on that domain. I already graphed them both. The relationship between the two graphs is that they are reflected over the line y equals x. The last thing we need to do is we need to specify the domain and the range of each. The domain of f extends from 1 to positive infinity, and the range of f starts at 0 and goes to positive infinity. Vice versa, the domain of the inverse starts at 0 and goes to positive infinity, and the range of the inverse starts at 1 and goes to positive infinity. Oh, forgot my parentheses. Okay. Next, we're going to look at these two, and it says that they are inverses of each other. Notice that f of 2 would be 2 cubed, which is 8. Notice that f prime of x would be 3x squared. That would mean that f prime of 2 is 12. F inverse of 8 would be the cube root of 8, which is 2. The derivative of that inverse, here's where it gets interesting. You're going to start by bringing down the power, subtracting 1 from the power, and if there's an inner function, you would worry about that, but there is not. I felt like I was missing a rule there. Okay, so we are going to bring down the power, 1/3, subtract 1 from the power, so we get negative 2/3. We could rewrite that as 1 over 3 cube root of x squared. Whether you choose the expression on the left or the expression on the right is up to you. I do happen to prefer the expression on the left. So now we're going to find the derivative of the inverse at 8. And when we replace x with 8 here, we get (1/12). Now, notice that C and F are multiplicative inverses. I think that's what it's called, multiplicative inverses. Somebody used to correct me on one of those things. I hope I'm using the right words. Okay, so 1 is 12 and 1 is 1/12. Well, that brings us to our next bit, and it's very, very useful. So, if G is the inverse of F, you can think of the derivative of that inverse as 1 over the derivative of the original function of G of X. I don't actually like the way that this is articulated, so I'm going to write a different notation here. Okay, so I really prefer the notation that I just put in there. The derivative of the inverse is the same as 1 over f prime of the inverse of the original fraction. I like these words here. Think flip a fraction, flip the order, an inverse derivative of an what? I don't know what that says. I don't like those words. If anybody can figure out what they're trying to say there, because your job. Okay. Sometimes all we are given is the pieces we need, and this is how they show up a lot. They're whether you're dealing with a calculus professor or you're dealing with the AP exam, they're always trying to look at the teeny tiny details to make sure that you did not just memorize a procedure. They want to make sure that you have an in-depth understanding of the mathematical concepts behind it. Because in order to major in math, which every math professor thinks that everybody should major in math, not become an engineer, you really need to understand the underpinnings of what's going on. So, I just bonked my head on my bicycle handlebars. We're going to look at f inverse prime of 5. So we are going, in order to find that, we're going to look at 1 over f prime of f inverse of 5. And in order to do that, we need to look at what our value of the inverse of 5 would be. F inverse of 5 would be 3. So now all we need to do is look at f prime at 3. And f prime at 3 is 7/2. So we get 2/7. Now mind you, this was a fairly straightforward problem. Oftentimes they're going to give you a lot of distractors so that if you put in one thing wrong, the correct answer still could be, the incorrect answer could still be on the page. So be super careful here. Make sure you actually memorize inside out and backwards and forwards the derivative of an inverse. When we're not given all the pieces, we might need to find f inverse of a and f prime of x before we can use the formula. So this has always been one of my favorite problems to do in class, because there's always somebody in class who knows the answer before I've even finished writing down the problem. They know exactly what x is. And the first time it happened, I was like, what kind of superhuman genius are you? And then there's only one number that works, y'all. And it's one of the easiest numbers to mess with. So we have 0 equals x cubed plus 2x minus 3. And remember, you're just being introduced to this material. Plug in 0, you get -3. 0 doesn't equal -3. Oh, let's try our next easiest number. Let's try 1. That's what everybody was doing. It was a gal. She just plugged in 1 and it worked. And she's like, that's just 1. And I was like, oh. When I figured out what she did, I was like, oh. But at the time, I was like, what? She can do that math in her head? What's happening? Okay. So we have an x value. F inverse of 2 would be 1. So now we're going to find the derivative of the inverse of f at 2. And when you do all the math, you should find 1/5. Now we're going to find the derivative of the inverse of g at 2. So first we need to find g prime of x, and we also need to figure out what value of x gives us a y value of 2. So by that I mean use this little doohickey to figure out what x is. We've got 4 equal to x plus 1. So 3 equals x. We also, again, need g prime of x, and g prime of x equals 1/2 times x plus 1 to the -1/2. that was a very big negative sign. We go back into our problem. G inverse prime of 2. And we get 1 over G prime of G inverse of 2. And G inverse of 2 was 3. So now we just need to find G prime of 3. And G prime of 3, when we do the math, would give us, I'm going to use a highlighter, I think. 3 plus 1 is 4. Square root of 4 is 2. Put that on the bottom of your fraction. And you get 1/4. 1 divided by 1/4 equals 4. Now we're going to look at the derivative of the inverse of the square root of 3 over 2. First, let's figure out what our function is when y is the square root of 3 over 2. And we're looking specifically on the interval from 0 to pi. On the interval from 0 to pi, cosine is the square root of 3 over 2, where x equals pi over 6. Now we need to figure out what the derivative of the original function is. F prime of x would be negative sine x. And the derivative of the inverse of the function in general, for this specific point, would be 1 over the derivative of the inverse at that specific point, and the inverse at that specific point was pi over 6, and the derivative was negative sine, and our x value is pi over 6. The sine of pi over 6 is 1/2, so we're actually looking at 1 over negative 1/2, and that simplifies to negative 2. And your Easter egg for today. Your test is Wednesday. Whoop!